Good afternoon, all. Welcome to the lecture of Advanced Discrete Mathematics. Screen is visible?
Yes, sir.
Okay. Okay, so in last lecture we have seen what is the principle of inclusion. That is some we have seen what it should be the cardinality of A union B. Similarly, we have seen what should be the cardinality of A union B union C. Okay, and after that we have seen why this principle is called as a principle of inclusion exclusion. That is here first we have to add the cardinalities of all the sets. Then those cardinalities we have to exclude those which are repeated. Again, whenever we have excluded the cardinalities somewhere for three set the cardinality is not included in our given formula, then again we have to include, again if it is repeated then we have to exclude, and we have to do it be continuously. Okay, so it depends what should be done, how many number of sets are there. Okay, so that one is nothing but the principle of inclusion and exclusion. So today we will see one another formula of a principle of inclusion exclusion. Let us see principle of inclusion and exclusion. Okay, so let us see what is the principle of inclusion and exclusion. There is an alternate form of principle of inclusion and exclusion that is useful in counting problems. It's useful in counting problems. Okay, so let us suppose some P1, P2 up to so on Pn, let P1, P2 up to so on Pn be any n properties. Pn properties. Okay, and Pi1, Pi2 up to so on Pik be any k properties among these n properties. So let Pi1, Pi2 up to so on Pik be any k properties among these n properties. So oh, the number of elements with all the properties, with all the properties Pi1, Pi2 up to so on Pik is denoted by n of Pi1, Pi2 up to so on Pik. Okay, so whenever Pi1, Pi2 be up to so on Pik be any k properties among the n properties, then the number of elements with all these k properties, that is Pi1, Pi2 up to so on Pik, is denoted by n of Pi1, Pi2 up to so on Pik. Okay, so if we have to write in these in terms of sets, if suppose AI1 be a set corresponding to the property Pi1, AI2 be a set which is corresponding to set Pi2, and up to so on AIK be a set corresponding to property Pik. As here, n of Pi1, Pi2 up to so on Pik denotes the number of elements with all the properties Pi1, Pi2 up to so on Pik. As here we have to take all the properties, it means it must be an intersection of all the elements. So writing these in terms of sets, writing these quantities quantities in terms of seats we have as here we have to take the number of elements with all the properties pi1 pi2 up to so on pik, where ai1 ai2 up to so on aik be the sets corresponding to the properties pi1 pi2 up to so on pik. It means here we have to take the intersection of all those elements. So intersection of ai1 intersection ai2 intersection ai3 and up to so on intersection aik is nothing but that is the cardinality of AI1 intersection AI2 intersection up to so on intersection AIK. It means the number of elements with all the properties PI1 PI2 up to so on PIK, and that one is nothing but n of PI1 PI2 and up to so on PIK. Okay. Yes, Kunal, काही doubt यामध्ये?
No, sir.
Okay. Okay. Now, if the number of elements in the set is denoted by, if the number of elements in the set is denoted by capital N, then what should be the number of elements with the properties P1 complement, P2 complement up to so on Pn complement. Okay, this one, this n of P1 dash P2 dash up to so on Pn dash denotes the number of elements with none of the properties P1 P2 up to so on Pn. It means if suppose we have to find out the number of elements with none of the properties P1 P2 up to so on Pn, then we have to use this formula. Okay, actually the number of elements in the set is denoted by capital N. N of P1 dash P2 dash up to so on Pn dash denotes the number of elements with none of the properties P1 P2 up to so on Pn. So what is its value? Capital N. That one is nothing but the total number of elements minus none of the properties. As here N of P1 dash P2 dash up to so on Pn dash is nothing but the number of elements with none of the properties P1 P2 up to so on Pn. It means we have to take A1 union A2 union up to so on union An. Since A1 union A2 union up to so on union An contains all the elements which satisfies the properties either P1 P2 up to so on Pn. As here we have to find out the n of P1 dash P2 dash up to so on Pn dash, that is the number of elements with none of the properties P1 P2 up to so on Pn. It means total number of elements minus the elements which satisfies the properties P1 P2 up to so on Pn. Okay, where n of P1 dash P2 dash up to so on Pn dash denotes the number of elements with none of the properties P1 P2 up to so on Pn. P1 P2 up to so on Pn. Okay. Now, what should be the cardinality of n of P1 dash? That is number of elements P1 dash P2 dash up to so on Pn dash then. Total n. And in previous lecture, we have seen one formula. What should be the cardinality of, as we know that cardinality of union over I running from 1 to n A. What should be its cardinality? Which is equal to? Yes, what is the cardinality of this set? Summation over I running from 1 to n cardinality of ai minus summation 1 less equal by I, which is less equal I less than some j, which is less equal by n, cardinality of ai intersection aj plus summation 1 less equal by I less than j, which is less than k less equal by n, cardinality of ai intersection aj intersection ak minus up to so on plus minus of 1 to the power n minus 1, cardinality of a1 intersection a2 intersection up to so on intersection an. This one is nothing but the cardinality of union over I running from 1 to n ai. Okay. Here either we can take I is equal to 1 or it can be written as 1 less equal by I, which is less equal by n, since I is running from 1 to n. Okay, so this will be the cardinality of union over I running from 1 to n ai, and n of p1 dash p2 dash up to so on pn dash is nothing but n minus cardinality of a1 union a2 union up to so on union an. So just here we have to put the value of this one. What should be the cardinality of this one then? Then here n minus summation over 1 less equal by I, which is less equal by n of pi. Here in this formula, here it is nothing but summation over 1 less equal by I, which is less equal by n, running from this one to I. As here we have taken n, there is no need to take here n. Okay, cardinality of AR. Okay, so but here A1 is nothing but, in this case, A1 is nothing but the number of elements with the properties P1, and which is denoted by n of P1. So this one is nothing but n of Pi or n of Pi. Since it, as here sum is running from 1 to n, so it is n of Pi. Okay, now plus summation 1 less equal by I less than j, which is less equal by n of Pi Pj. Okay, that one is here. Here it is nothing but all the elements which is satisfies, or it means ai intersection aj means all the elements which are belonging to both these sets. Okay, as here we have taken n of Pi Pj, it means all the elements which satisfies the properties Pi and Pj. Okay, yeah, so this one Pi Pj again minus summation 1 less equal by I less than j less than k less equal by n of Pi Pj and Pk. Okay, plus up to so on. Last one is nothing but minus of 1 to the power n of p1 p2 up to so on pn, which is just by using this formula, as we know that. Okay, it clear hai? Yes, इथपर्यंत कोणाला काही डाऊट?
No, sir.
Okay, just we have put this one here. Okay, this n of Pi Pj means the number of elements with properties Pi and Pj, but the set corresponding to Pi is ai, the set corresponding to Pj is aj. As here we have to take the number of elements with both the properties at a time, it means we have to take the intersection of that two sets, that is ai intersection aj, and that one is nothing but this one. Either we can write this one or this one, both have the same value. Okay, so this will be the formula to find out the number of elements with none of the properties P1, P2 up to so on Pn. Okay, let us see one example. Use the principle of inclusion-exclusion to find the number of primes less than 100. Less than 100 means here we have to check up to 99 only. Okay, that is here capital N is nothing but 99. Here we have to find out the number of primes less than 100. It means the value of N will be 100. But in number theory, we have seen one result, that is the composite integer is divisible by not a composite integer is divisible by a prime not exceeding its square root. That is, we know that a composite integer, as here 100 is a composite integer, and we have to find out the number of primes less than 100. As we know that a composite integer or composite number is divisible by a prime, divisible by a prime not exceeding its square root. Its square root. Okay, it means if n is any composite integer, then it is divisible by a prime not exceeding its square root. It means if n is any composite integer, So this n is not divisible by any prime which is greater than the value of root n. Okay, for example, if suppose value of n will be equal to some 16, okay, as it is a composite integer, then this 16 is not divisible by any prime having value is greater than a root 16, that is 4. Okay, let us check what are the primes less than 4. 2 and 3 are the two
2, 3.
primes that are less than 4. So this 4 is divisible by 2. Okay. But according to this one, this 4 is not divisible by any prime which is greater than 4. The primes which are greater than 4 are nothing but 5, 7, 11 and 13. Up to 16 we have to check. So it is not divisible by 5. 16 is not divisible by 5. Also it is not divisible by 7. Same for 11 and 13. So just we have to use this result for solving this one. Okay, so as we know that any composite integer is divisible by a prime not exceeding its square root. As here the value 100 is given, as we have to find out the number of primes less than 100, then 100 is not divisible by a prime divisible by a prime exceeding रूट 100 दॅट इज इक्वल टू 10. म्हणजे हा 100 जो आहे माझा डिव्हिजिबल जर असेल एखाद्या प्राइमनी तर जे व्हॅल्यू 10 पेक्षा लहान आहेत त्याच्याने डिव्हिजिबल असेल. कारण या रिझल्टवरून याच्यापेक्षा 10 पेक्षा जो काही मोठा माझा प्राइम असेल त्या व्हॅल्यूनी हा 100 कधीही डिव्हिजिबल नसेल. नो, नाउ टेल मी व्हॉट आर द प्राइम्स लेस दॅन 10.
2, 3, 5, 7.
So 2, 3, 5 and 7 are the primes less than 100. Okay, and we have also seen the CO of Eratosthenes. In that we have seen it is a method to find out the primes. Okay, that is just we have to use. As 2, 3, 5 and 7 are the only primes which are less than 10. Okay, now this root 100 is not divisible by any prime which is exceeding this square root value. Okay, so first we will find out the integers which are divisible by 2, 3, 5 and 7. That is the number of integers in between 1 to 100 and that are divisible by 2, 3, 5 and 7. Okay, so let Pi where I running from 1 to 3, 4. Since here there are 4 numbers, that is 2, 3, 5 and 7, and we have to find out the integers which are divisible by 2, divisible by 3, divisible by 5 and divisible by 7 separately. Be the, so let Pi be the property that an integer is divisible by 2, 3, 5 and 7 respectively. Thus the number of primes less than 100 is less than 100 is just by using the CO operator, the method of CO operative things. That is, we have to just eliminate the multiples of 2, multiples of 3, multiples of 5 and element multiples of 7. Then the remaining numbers are nothing but the number of primes less than 100. Okay, so actually we have, there are 4 primes which are less than 10. So that 4, thus the number of primes less than 100 is 4 plus n of P1 dash, P2 dash, P3 dash and P4 dash. Since Pn of P1 dash, P2 dash, P3 dash, P4 dash denotes the number of elements with none of the properties P1, P2 up to so on P4. It means the number of integers which are not divisible by 2, 3, 5 and 7, and that integers which are not divisible by 2, 3, 5 and 7 are obviously the prime integers. Okay, so the total number of primes less than 100 is nothing but that 4 values, that is 2, 3, 5 and 7. These are the 4 in numbers plus n of P1 dash, P2 dash up to so on P4 dash. So it remains to find out the value of n of P1 dash, P2 dash, P3 dash, and P4 dash. But by the principle of inclusion exclusion, by the principle of inclusion exclusion, what is the value of this n of P1 dash, P2 dash, P3 dash, and P4 dash? Yes, what is its value? N minus n of, that is summation 1 less equal by I less equal by n of Pi. It means the number of elements with the properties Pi, where I here is running from 1 to 4, minus n of P1 minus n of P2 minus n of P3 minus n of P4 plus n of P1 P2 plus n of P1 P3 plus n of P1 P4 plus n of P2 P3 plus n of P2 P4 plus n of P3 P4 minus n of P1 P2 P3 minus n of P1 P2 P4 P1 P2 P4 minus n of P1 P3 P4 P1 P3 and P4 minus n of P2 P3 P4. These are the possible combinations with three properties, plus last one is nothing but n of P1 P2 P3 and P4. Okay, so this will be the formula for n of P1, the number of elements with none of the properties P1 P2 P3 and P4. Just we have to find out the values of this n of P1, n of P2, n of P3 and so on. Now n of P1, it means the number of elements in between 1 to 100 with the property P1. But what is the property P1? P1 is nothing but the number of integers which are divisible by 2. So how many integers are there in between 1 to 100 which are divisible by 2? That is, actually we have to find out all the numbers which are multiples of 2. Actually this value is equal to greatest integer value of 100 divided by 2.
50.
Yes, na?
Yes, sir.
Okay, so how many integers are divisible by 2? The greatest integer value of 100 divided by 2. That one are nothing but the multiples of 2. And that one is nothing but n of P1. So what is the greatest integer value of 100 divided by 2? Which is nothing but 50.
50.
And what is greatest integer value of 50? Which is equal to 50. Similarly, what is n of P2? Is nothing but 100 divided by P2, the integers which are divisible by 3 and that are in between 1 to 100. So it is nothing but greatest integer value of 100 divided by 3, which is equal to, what is the 100 divided by 3 is nothing but
33.3.
33.3, but which is equal to the greatest integer less not greater than that element, which is equal to the
33.
is
33.
33. Similarly, n of P3 is equal to 100 divided by 5. 100 divided by 5 is nothing but
20.
which is 20.
20.
Similarly, n of P4 equal to greatest integer value of 100 divided by 4, and which is equal to
40.
which is 40. Now, n of P1 P2. N of P1 P2 means here we have to find out the number of integers which are divisible by 2 and 3. Since P1 is nothing but the property, the number of integers which are divisible by 2. P2 is nothing but number of integers which are divisible by 3. But n of P1 P2 is nothing but the number of integers which are divisible by both 2 and 3. Either we can find out the number of integers, that is n of P1 P2 means 100 divided by LCM of 2 and 3 or 2 into 3. That is, this one is nothing but the number of integers which are divisible by 2 and 3. Since those integers are divisible by 2 and 3, which are the multiples of 2 and 3. Okay, so 100 divided by 2 into 3 is nothing but the number of integers which are divisible by both the integers 2 and 3. कुणाला काही डाऊट यामध्ये?
No, sir.
एक
No,
ते
sir.
100 मधून मला असे इंटीजर काढायचे जे की 2 आणि 3 दोन्हींनी डिव्हिजिबल असतील. तसे इंटीजर कोणते असतील? जे 2 आणि 3च्या मल्टिपल मध्ये असतील ते इंटीजर माझे 2 आणि 3 नी डिव्हिजिबल असतील. मग काय असेल, कशा कोणत्या फॉर्म मध्ये असतील ते? व्हॉट शुड बी द एलसीएम ऑफ 2 and 3? That one is nothing but the number of integers which are divisible by both 2 and 3. Just we have to find out the multiples of that LCM. What is the multiple of 2 and 3? Which is nothing but 6. Either we can take 2 into 3 or LCM of 2 and 3. Both are the same things, which is nothing but 100 divided by 6, which is equal to
60.
60.
60. Similarly, n of p1 p3 equal to the number of integers which are divisible by 2 and 5, which is equal to
10.
10.
10.
Similarly, n of p1 p4 equal to 100 divided by 2 into 7 equal to, yes, what is this value?
7.
Which is equal to
7.
7. N of p2 p3 is equal to greatest integer value of 100 divided by 2 is nothing but 3, that is p2 is 3 and p3 is 5. Yes, 100 divided by 15,
6.
which is equal to 6. N of p2 p4 is equal to greatest integer value of 100 divided by p2 is nothing but 3, p4 is 7. Yes, 100 divided by 21.
4.
4.
Just we have to find out the greatest integer value. So n of p3 p4, 100 divided by p3 is nothing but 5, p4 is 7. 100 divided by 35, I think, which is equal to 2.
2.
So next one is nothing but n of p1 p2 p3, 1 p2 p3. Yes, greatest integer value. Now here we have to find out the number of integers which are divisible by 2, 3 and 5 at a time. So it is nothing but the LCM of 2, 3 and 5. That is 2 into 3 into 5. Yes, which is equal to
1.
3.
yes,
3.
5 into 3, 15 into 2, 30, 30, 60, 90. Yes, 3. N of P1, P2 and P4 is nothing but 100 divided by 2 into 3 into 7. Yes, 7 into 2, 21. Sorry, 21 into 2, 42. 42 means it is equal to 2. N of P1, P3, P4 is equal to greatest integer value of 100 divided by 2 into 5 into 7. 7 into 5, 35 into 7. So what is its value? I think 1. Okay, next one, n of p2 p3 p4 is equal to 100 divided by 3 into 5 into 7, which is equal to 35 into 3, 105. 100 divided by 105 is point something. So what is the greatest integer value?
0.
0. And last one is n of p1 p2 p3 and p4, and which is equal to 100 divided by 2 into 3 into 5 into 7. As 3 into 5 into 7 is 105. 105 into 2 is 210. So 100 divided by 210 and its greatest integer value is again 0. Just put the put these values in equation 1. Put these values in 1, we get. Okay, that is, give this one as equation number 1. So which implies n of p1 dash p2 dash up to so on p4 dash is equal to n. N is nothing but, as we have to find out the number of integers less than 100, so it is nothing but 99 minus of n of p1 plus minus n of p1 minus n of p2 minus n of p3 minus n of p4. Just here we will take minus common and add all those values. What are these values? 50 plus 33 plus 20 plus 14 plus n of p1 p2 p3 n of p1 p2 p4. That is, we have to add all those values. What are those values? Sorry, first we have to take the two properties, that is 16 plus 10
10.
plus 7 plus 6 plus 4 plus 2 plus, sorry, I think up to 2, minus. Now for the third, that is third property, that one is nothing but 3 plus 2 plus 1 plus 0, and last one is equal to 0. So which is equal to 99 minus 50 plus 33, 83 plus 20, 103, 103 plus 14,
117.
117, 117 plus 16 plus 10, 26 plus 7, 33 plus 6, 39 plus 6, 45 minus 3 plus 2 plus 1, 6, which is equal to 99 plus 45, 144 minus 117 minus 6, sorry, 117 plus 6, 123, which is equal to 144 minus 123,
21.
which is equal to 21. So hence the number of primes less than 100 is equal to how much?
25.
Yes, that 4 plus this 21, and which is equal to 21. Okay, so in this way we can find out the integers which are in between 1 to 100 and they are prime. Yes, up to now, any doubt?
No, sir.
Okay. Now the next concept is nothing but the pigeonhole principle. Pigeonhole principle, which is also called as a Dirichlet drawer principle or shoebox principle. That is Dirichlet drawer principle or shoebox principle. Okay. So first let us see its statement. If n pigeons are are assigned to m pigeonholes, then at least one pigeonhole, then at least one pigeonhole contains two or more pigeons. Whenever m is less than n, that is number of pigeonholes are less than the number of pigeons. Okay, if suppose there are n pigeons and m pigeonholes, where m is less than n, where that is m number of pigeonholes are less than the number of pigeons, then at least one pigeonhole contains two or more pigeons. Okay, हे प्रूव्ह करायची काय गरज आहे का? जर माझ्याकडे समजा 10 पिजन होल आहेत, आणखीन जर 15 पिजन्स असतील, आणखीन प्रत्येकामध्ये जर मला कमीत कमी एक जर एक जरी नाही ठेवला तरी प्रॉब्लेम, इथं अशी काही कंडिशन नाही आहे की एकामध्येच किती ठेवावं. बट अरेंजमेंट कसंही करा, पण जर माझ्याकडे 10 पिजन होल असतील, आणखीन 15 पिजन असतील, तर ही कंडिशन काय सांगेल, तर हा स्टेटमेंट काय सांगेल, कमीत कमी एका पिजन होलमध्ये माझ्या एक किंवा सॉरी 2 किंवा 2 पेक्षा जास्त असतील. कारण असायलाच माझ्याकडे किती आहेत? 10 पिजन होल आहेत, 15 पिजन आहेत. जरी मी प्रत्येकामध्ये एक जरी ठेवलं तरी 10 सोबत 10 गेले, राहिले 5. माझे 5 या 10 मध्येच अरेंजमेंट करायची आहे. मग मी ते 5 मी कसंही करेन. प्रत्येक कोणत्याही 5 मध्ये एक ऍड करेन, एकामध्येच 5 ऍड करेन किंवा 2 मध्ये 2 करेन, एकामध्ये 1 करेन. पण कसंही जरी तुम्ही अरेंजमेंट केला तर या पिजन होल प्रिन्सिपल नुसार काही कमीत कमी माझ्याकडे असा एक पिजन होल असेल, त्यामध्ये 2 किंवा 2 पेक्षा जास्त पिजन असतील. ठीक आहे.
Yes, sir.
Let us see the proof. Okay. Let m pigeonholes be numbered with. Let m pigeonholes be numbered with the numbers 1 through m. Okay, just here we have given the numbering for the pigeonholes. So beginning with the pigeon 1, each pigeon is assigned in order to the pigeonholes with the same number. Okay, first we will fill up the each pigeonhole with corresponding pigeons. But as here m is less than n, that is the number of pigeonhole, that is the number of pigeonhole is less than the number of pigeons so n minus m pigeons, as there are m pigeonholes and n pigeons, here we have filled up each pigeonhole by one pigeon, then there are remaining n minus m pigeons are left. Okay, so n minus pigeons are left, pigeons are left without having a pigeonhole, without having assigned a pigeonhole. Thus, from this one we conclude that thus at least one pigeonhole will be assigned to a more than one pigeon. ओके, जे काही माझ्याकडे एन मायनस वन एम पिजन राहिले ते मी एक तर एकाच पिजन होलमध्ये फिलअप करेन किंवा परत मी एक 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 ऍड करत जाईल. पण मला कमीत कमी एक असा पिजन होल मिळेल ज्यामध्ये एकापेक्षा जास्त पिजन्स मला मिळतील. तेच म्हणजे 2 किंवा 2 पेक्षा जास्त पिजन मिळतील. ओके, इथं काय माझा पिजन होल प्रिन्सिपल काय सांगतो, फक्त मला एक असा पिजन होल मिळेल ज्यामध्ये एक किंवा एकापेक्षा जास्त पिजन्स त्यामध्ये मिळते. पण तो पिजन होल कुठं असेल, त्याचं नेचर काय असेल याबद्दल काही सांगत नाही. ओके, ठीक आहे. सो वी नोट दॅट हिअर देयर इज वन नोट. Pigeonhole principle so, principle tells us nothing about how to locate the pigeonhole that contains two or more pigeon, contains two or more pigeons. Okay, it only asserts that only asserts that the existence of a pigeonhole, the existence of a pigeonhole containing two or more pigeons containing two or more pigeons. ओके. म्हणजे काय, जे काही माझा पिजन होल असेल ज्यामध्ये दोन किंवा दोनपेक्षा जास्त पिजन आहेत, तो लोकेट कसं करायचा, तो कुठं आहे, त्याच्यामध्ये किती एलिमेंट भरायचे याबद्दल काहीही सांगत नाही. फक्त तो असं सांगतो की असा एक पिजन होल एक्झिस्ट होईल ज्यामध्ये दोन किंवा दोनपेक्षा जास्त पिजन्स असतील. ओके. सो टू अप्लाय द प्रिन्सिपल वन हॅज टू डिसाइड which object will play the role of pigeon and which object will play the role of pigeonholes. Then only we can apply the pigeonhole principle. If we have a problem, then we have to check which object will be play a role of pigeons and which will be play a role of pigeonhole. Okay, let us see for example. Yes, first pigeonhole principle मध्ये कोणाला काही डाऊट आहे का?
No, sir.
No, sir.
Now, in a group of 13 children, in a group of 13 children, there must be at least two. There must be at least two children who were born in the same month. Who were born in the same month. How many children are there? 13 children are there. Okay, and we have to check whenever we have 13 children, there must be at least two children who were born in the same month. How many months are there? There are 12 months. Okay, so let us see the solution. As there are 12 months and given that 13 children are there and 13 children. Okay, now which will play the role of pigeons and which will play the role of pigeonhole? The months play the role of pigeons and 13 children play the role of pigeons. Sorry, 12 months play the role of pigeonholes and 13 children play the role of pigeons.
Pigeon.
Since 12 is less than 13, so months of the year months of the year play the role of pigeonhole and 13 children play the role of pigeons. Role of pigeons. Okay, as there are 12 months and 13 children and 12 is less than 30, that is the number of pigeonholes are less than the number of pigeons. Then by the pigeonhole principle, yes,
In a month, at least two children should be born.
pigeonhole principle, out of 13, there must be at least two, must be at least two who were born in the same month. Born in the same month. Since here there exists one month that contains two or that is there exists at least one month in which there are two or more children that is born of two or more children. Okay, and that is we have to prove. Now the next one. Show that if any five integers from 1 to 8 are chosen, 1 to 8 are chosen, then at least two of them will have a sum 9. Sum is equal to 9. Okay, so there are integers from 1 to n, and we have, if we choose any 5 among them, then at least 2 of them will have sum will be equal to an integer 9. Okay, this one is the 9. Okay, see the solution. Let capital A be a set which contains an integers 1, 2, 3, 4, 5, 6, 7, and now, what are the possible combinations whose sum is equal to 9? First set we will contain A1. If we take the first element as a 1, then what is an second element having sum with 1 is equal to 9?
8.
8.
8.
8.
Similarly, set A2. If we have taken 2, then
7.
7 we
7.
have to take. Similarly, set A3, whenever we will take 3, then corresponding element will be 6, and A4 is nothing but 4 and 5. Next is nothing but combination 6, but 6 and 3 is already there, and there is no integer other than 3 having sum with 6 is equal to 9. जे केव्हा जर ते एलिमेंट यामधून घेतले तर ए इक्वल टू 1 2 3 4 5 6 7 and 8. So these are the possible combinations of an element having sum is equal to 9. Okay, if one is there, then another element must be equal to 8. Now we have to prove that if we choose any 5 integers from this A, then there must be at least 2 elements having sum is equal to 9. Okay, so each of the 5 numbers chosen from 1 to 8 must belong to one of these sets. If we choose any 4 integers, arbitrary choose, if we choose 1 3 and 1 3 6 and 8, okay, suppose 1 3, let us check 6. If we take a 6, then 6 plus 3 is 9. We will take some another element 5, and last one is nothing but 7. So these are the any arbitrary elements 1 3 5 and 7. So here we have chosen 4 numbers, but we have to choose one another number. Let us choose one another number except these 1 3 5 and 7. Yes, एखादा नंबर सांगा 1 3 5 7 ला सोडून आणखीन तो ए मध्ये असला पाहिजे. येस, आवाज
2,
येते ना
sir.
माझा? जर 2 घेतला समजा, 2 घेतला तर 2 प्लस 7 माझा 9 होईल. 2 ला सोडून दुसरी पॉसिबिलिटी काय आहे माझी? 4 घेऊ शकतो. 4 घेतला तर 5 सोबत जाईल. नंतर काय आहे, 6 आहे, 6 घेतला तर तो 3 सोबत जाईल, आणि 8 घेतला तर तो 1 सोबत जाईल. म्हणजे जर मी आर्बिट्री कोणतेही 4 नंबर जर चूज केले, तर 5वा नंबर तुम्ही जो काही निवडेल त्याचा सम हा एखाद्या एलिमेंट सोबत जर केला तर तो मस्ट बी 9 येईल. हे कधी जर 1 3 5 7 यामध्ये 2 एलिमेंट नसतील माझे, ज्यांचा सम हा 9 नसेल. पण जर यामध्येच जर तुम्ही चूज केला, फॉर एक्झाम्पल इथं जर 6 चूज केला, तर इथंच माझे 2 एलिमेंट आहेत ज्यांचा सम हा माझा 9 आहे. ठीक आहे. So the 4 sets, that is these A1 A2 A3 A4, the 4 sets can be considered as, the 4 sets can be thought of as, can be thought of as pigeonholes, and 5 chosen numbers, 5 chosen numbers as pigeons. Okay, so as 4 is less than 5, then by the pigeonhole principle, the number of pigeonholes less than the number of pigeons, any two of the selected numbers must belonging to the same set whose sum is equal to 9. So by pigeonhole principle, we conclude that two of the selected numbers must belong to the same set. whose sum is 9. And that is we have to. Okay? Yes. कुणाला काही डाऊट यामध्ये
No.
ठीक आहे आणखीन काही प्रिन्सिपल आहे पिजन होल प्रिन्सिपलचे जनरलाइज पिजन होल प्रिन्सिपल एक्सटेंडेड पिजन होल प्रिन्सिपल अँड पिजन होल प्रिन्सिपल ऑफ सेकंड फॉर्म ओके दॅट विल बी विल सी इन द नेक्स्ट lecture leave the meeting